Ever looked up at the night sky and wondered, what's out there? What lies beyond the twinkling stars and the glowing moon? It's a question that has fascinated humanity for as long as we've been able to look up and ponder the vastness above us. It's a question that's puzzled humans for centuries. Ancient astronomers spent their lives charting the stars, trying to make sense of the cosmos. They used rudimentary tools, but their curiosity was boundless. We've come a long way from thinking Earth was the center of everything. Back then, it was believed that all celestial bodies revolved around our planet. This geocentric model was widely accepted until the Renaissance. Today, with advanced technology and powerful telescopes, we're grappling with an even bigger question: what's at the center of the universe? Our quest for knowledge has led us to some astonishing discoveries. Now, you might be picturing a giant, glowing orb or maybe even a black hole. These are common images that come to mind when we think of something central and powerful in the universe. But the answer, my friends, is a lot more mind-blowing. The universe, as we understand it, is far more complex and mysterious than we ever imagined. The universe, as far as we understand it, doesn't have a center. This concept is difficult to grasp because we're used to thinking in terms of centers and edges. I know, it sounds crazy, right? How can something so vast and expansive not have a central point? It's a mind-bending idea that challenges our perception of space and structure. But stick with me here. The universe is expanding, and every point in it is moving away from every other point. This means that no matter where you are in the universe, it looks like you're at the center of the expansion. To understand why there's no central point in the cosmos, we need to rewind the clock about 13.8 billion years to an event called the Big Bang. This monumental explosion didn't happen at a single point in space, but rather everywhere at once, setting the stage for the universe we know today. Imagine all the matter and energy in the universe crammed into a space smaller than an atom. This incredibly dense and hot point contained everything that would eventually become our universe. That's the Big Bang in a nutshell. It marks the moment when this tiny, dense point began to expand and cool, leading to the formation of the universe as we know it. It wasn't an explosion in the traditional sense, like a firework going off. Instead of a chaotic blast, it was a smooth, rapid expansion. Instead, it was a rapid expansion, everything flying outward from a single point. This expansion happened everywhere at once, not from a single location. Think of it like baking a loaf of raisin bread. As the dough rises, the raisins, representing galaxies in this case, move further apart. As the dough rises, the raisins, representing galaxies in this case, move further apart. This analogy helps us understand how galaxies are not moving through space, but rather with space. Now imagine that raisin bread expanding in all directions, infinitely. This gives us a sense of how the universe is expanding uniformly in every direction. That's kind of what happened with the Big Bang. The universe has been expanding ever since, and it continues to do so today. The key takeaway here is that the Big Bang wasn't an explosion in space, it was an expansion of space itself. This distinction is crucial for understanding the nature of our universe. Space itself was stretching, carrying galaxies with it, rather than galaxies moving through a pre-existing space. And because space is expanding everywhere at once, there's no single stationary point that we can call the center. Every point in the universe is moving away from every other point, making the concept of a central point meaningless. This ongoing expansion shapes the cosmos, influencing everything from the formation of galaxies to the ultimate fate of the universe. So, how do we know the Big Bang even happened? Well, we have some pretty convincing evidence. Cosmic microwave background radiation. This faint afterglow of the Big Bang permeates the entire universe. Think of it like the heat you feel coming off a hot stovetop even after you've turned it off. The Big Bang was like turning on the stove, and the cosmic microwave background radiation is the residual heat, still lingering billions of years later. This radiation is remarkably uniform, meaning it has almost the same temperature in every direction we look. This uniformity is strong evidence that the universe originated from a single, incredibly hot and dense state, exactly what the Big Bang theory predicts. Section 4. Expanding Horizons. How the universe grows. Here's where things get really interesting. The universe isn't just expanding, it's accelerating. Imagine driving a car and stepping on the gas pedal harder and harder. That's what's happening to the cosmos. This acceleration is driven by something scientists call dark energy, a mysterious force that makes up about 68% of the universe's total energy density. We don't fully understand dark energy yet, but we know it's pushing everything in the universe farther and farther apart. This continuous expansion means that the idea of a fixed center becomes meaningless. There's no middle to speak of because every point in space is moving away from every other point. Section 5. A centerless universe. Shifting perspectives. Think about it this way. If you were an ant living on the surface of an expanding balloon, you wouldn't be able to find the center of the balloon's surface. No matter how far you walked, you'd always be surrounded by more balloon. The universe is kind of like that expanding balloon. We're like ants on its surface, and our perception of a center is limited by our three-dimensional perspective. The mind-bending reality is that every point in the universe can be considered the center from its own perspective. Section 6. Raisin bread and galaxies. Visualizing expansion. Remember that raisin bread analogy? As the dough expands, the raisins move further apart. But here's the thing. Each raisin sees itself as stationary, and all the other raisins as moving away from it. The same goes for galaxies in our universe. From our perspective here on Earth, it seems like all the other galaxies are moving away from us. But from the perspective of another galaxy, it looks like we're the ones moving away. The key here is that there's no single correct perspective. Every point in the universe is valid as a reference point, which further reinforces the idea that there's no absolute center. Section 7. The universe's biggest mystery and ever-expanding frontier. So, there you have it. The universe, in all its vastness and wonder, doesn't have a center in the traditional sense. This concept is not just a scientific curiosity, but a profound philosophical revelation. Imagine standing on a planet orbiting a distant star, looking up at the night sky. You would see the same vast expanse of stars and galaxies as we do from Earth. The universe, in all its vastness and wonder, doesn't have a center in the traditional sense. It's an incredibly humbling and awe-inspiring concept that challenges our understanding of space and time. The Big Bang, cosmic microwave background radiation, and the accelerating expansion of the universe all point to a cosmos without a central point. It's an incredibly humbling and awe-inspiring concept that challenges our understanding of space and time. The Big Bang, cosmic microwave background radiation, and the accelerating expansion of the universe all point to a cosmos without a central point. This means that every point in space is as good as any other, a truly egalitarian universe. And the accelerating expansion of the universe all point to a cosmos without a central point. Every point in space is as good as any other, a truly egalitarian universe. This idea is not just a scientific abstraction, but a reality that we can observe and measure. Every point in space is as good as any other, a truly egalitarian universe. And as we continue to explore the cosmos, unraveling its mysteries and pushing the boundaries of human knowledge, we are constantly reminded of our place in this vast, ever-expanding frontier. And as we continue to explore the cosmos, unraveling its mysteries and pushing the boundaries of human knowledge, we are constantly reminded of our place in this vast, ever-expanding frontier. The tools and technologies we develop, from powerful telescopes to space probes, allow us to peer deeper into the universe than ever before. One thing remains certain: the universe, with its lack of a center, will continue to captivate and inspire us for generations to come. The more we learn, the more we realize how much there is yet to discover. This endless quest for knowledge is what drives us to look up at the stars and wonder about our place in the cosmos. The universe, with its infinite possibilities, will always be a source of inspiration and awe.